Welcome to another interesting lecture on spectroscopy. In the last lecture, we talked about the electromagnetic spectrum. We said that it is the range of all possible frequencies of electromagnetic radiation in order of increasing frequency and decreasing wavelength. Today, we will be looking at spectroscopy, which is a scientific technique used to study the interaction between matter and electromagnetic radiation. Don't forget to subscribe, like, comment, and share this video. Remember, subscribe, like, comment, and share this video. The objective of the lesson is that by the end of the lesson, the student should be able to define spectroscopy, outline some common spectroscopic techniques, identify the information given by spectroscopy, and identify some of the applications of spectroscopy. What is spectroscopy? Spectroscopy is a scientific technique used to study the interaction between matter and electromagnetic radiation. It focuses on measuring the absorption, transmission, or emission of radiation by atoms or molecules as a function of frequency or wavelength. It provides information about the energy levels, structures, and properties of molecules. What's the difference between spectroscopy and spectrometry? Spectroscopy is the science of studying the interaction between matter and radiated energy. It is the theoretical approach to science. While spectrometry is a method used to acquire a quantitative measurement of the spectrum, it is the practical application where results are generated. It quantifies the amounts of radiation absorbed, transmitted, or emitted. It provides information about the concentration, amount of, or identity of molecules. A spectrometer is the equipment used to measure the wavelength and frequency of light, which allows us to identify and analyze the atoms in a sample placed in it. Types of spectroscopy. We have different types of spectroscopy. We have the atomic absorption spectroscopy, which measures the absorption of light by atoms. We have atomic emission spectroscopy that measures the emission of light by atoms. We have infrared spectroscopy. It measures the absorption of infrared radiation by molecules. We have ultraviolet spectroscopy. It measures the absorption of ultraviolet and visible radiation by molecules. Nuclear magnetic resonance. It measures the absorption of radiation by atomic nuclei. We have mass spectrometry. It measures the mass to charge ratio of atoms. We have fluorescence spectroscopy. It measures the emission of light by excited molecules. Raman spectroscopy measures the scattering of light by molecules. We have X-ray spectroscopy. It measures the absorption of X-rays by atoms. We have gamma spectroscopy, measures the absorption and emission of gamma rays by atomic nuclei. We have electron peak resonance spectroscopy. It measures the absorption of radiation by unpaired electrons. Masbach spectroscopy measures the absorption of gamma rays by atomic nuclei. Photoelectron spectroscopy measures the energy of electrons emitted by atoms. And the Argon electron spectroscopy measures the energy of electrons emitted by atoms. These types of spectroscopy are used in various fields, including chemistry, physics, biology, and material science, to analyze the properties of atoms and molecules. What are the information we get from spectroscopy? By analyzing the radiation absorbed, emitted, or scattered by a sample, spectroscopy provides valuable information about the chemical identity of the compound, the concentration of the compound, the structure, the properties, the electronic transition, and the vibrational modes of the compound that we are analyzing. Are the laws of spectroscopy. We have two laws of spectroscopy. We have the first law, which states that all atoms emit and absorb radiation at various wavelengths of the electromagnetic spectrum, which are unique for each element. We have the second law, that the intensity of the spectral line of the element is proportional to the concentration of that element. And the emission and absorption spectra provides a fingerprint of the sample that is a qualitative analysis. This was first discovered in 1860 by Gustav Robert Kirchhoff and Robert Wilhelm Bunsen. They published in their landmark paper, and they discovered cesium and rubidium using this new technique of spectroscopy. Chemical identity spectroscopy and structures. What is it all about? In chemical identity, we have several spectroscopies that help us to give us information about the structures of molecule, compounds, or ions. IR provides information about molecular vibrations, which can be used to identify functional groups and molecular structure. So if you want to know the functional group of a compound, you must use your IR to determine it. We have the NMRO, which gives us, that is the nuclear magnetic resonance, which gives us information about molecular structure, including atoms, connectivity, and electron density. We have the mass spec, which determines the mass to charge ratio of atoms, which can be used to identify molecular weight and fragmentations. We also have the UVVs, which is the ultraviolet visible, which provides information about electronic transitions, which can be used to identify conjugated dienes and molecular structure. We have the Raman. Raman spectroscopy offers information about molecular vibration, just like IR, but with different selection rules. We also have the X-ray crystallography. Three-dimensional arrangement of atoms within a molecule will be gotten when you look out or you use the X-ray crystallography. We have the electron peak resonance. Talks about unpaired electrons, which can be used to determine molecular structure and conformation. And then we have the Mossbauer spectroscopy. It talks of electronic environment of atoms to describe the molecular structure and conformations. What are the importance of vibrational frequencies? We understand that by analyzing vibrational frequencies and intensities in a spectrum, we can determine different functional groups such as hydroxyl, carbonyl, amino or amine, and alkyne. We know that each functional group has specific frequency range, and the vibrational frequencies are related to bond strength and length. It also helps us to elucidate molecular conformation and identify molecular symmetry. Spectroscopic combinations to determine structures. How do you combine different spectroscopies to determine the structures of molecules? You can use the IRO and NMRO. IRO and NMRO, which is infrared and nuclear magnetic resonance spectroscopies, are used to determine molecular structures. It's also important that you use the mass spec and the NMRO also. You can also use them to determine molecular weight and structures of the compounds. We can use the UVV spectroscopy. It is often used to identify conjugated systems and complement IRO and NMRO. So most times when you are using your UVVs in research, you should also find out, you also use infrared and nuclear magnetic resonance. Because by combining data from multiple spectroscopic techniques, scientists can confidently determine chemical identity. Spectroscopies that measures concentrations. We have the absorption spectroscopy, that is the UVVs and the IR. They talk about the absorption of radiation by a sample, which is directly proportional to the concentration of the absorbing species. We can use the fluorescence spectroscopy. It measures emission of radiation by a sample, and that is directly proportional to the concentration of the fluorescent species. We also have the atomic absorption spectroscopy, generally known as AAS, which measures the radiation by atoms, and it tells us that it is directly proportional to the concentration of the elements. We have the mass spectrometry, measures the intensity of ion signals, which are directly proportional to the concentration of the ions. And the nuclear magnetic resonance, it measures the intensity of nuclear magnetic resonance signals, which is directly proportional to the concentration of the nuclei. We have the Raman spectroscopy, measures the scattering of radiation by molecular vibrations, which can be used to determine concentration. And we have the X-ray fluorescence. It measures the absorption of radiation by a sample, which is directly proportional to the concentration of the elements. What are some of the applications of spectroscopy? Spectroscopy is widely applied in chemistry for the identifying and analyzing of molecules, determining chemical structures and composition, and monitoring chemical reactions. It's useful in biology and medicine for the studying of biomolecules and their interactions, diagnosing diseases such as cancer and diabetes, imaging tissues and cells. It's also very useful for environmental issues or environmental studies in monitoring air and water pollution, analyzing soil and water samples. We use spectroscopy for material science in characterizing material properties and composition. Pharmaceuticals, identifying and analyzing pharmaceutical compounds, monitoring drug interactions. Spectroscopy analysis are useful for forensic science in investigating crimes, analyzing evidence, fingerprintings, and DNA. It is useful in astronomy, analyzing celestial object composition and properties. Spectroscopy is useful for quality control, monitoring manufacturing processes, determining defects and contaminants. Very, very useful for research and development, exploring new materials, analyzing new technologies, developing new analytical techniques. Spectroscopy is very useful in most areas of research. What are the study questions for this lecture as we have come to the end of this lecture? We want you to know how to define spectroscopy, list 5 spectroscopic techniques, what are the 6 useful informations obtained from spectroscopy, what are the importance of vibrational frequencies, explain the importance of spectroscopic combination in a research. Thank you for listening to this video to the end. Don't forget to subscribe, like, comment, and share this video. See you in the next lecture.